All right, let's dive in. Today, we're going to peel back the curtain on NVIDIA's kit-CAE. We're talking about the tech that lets you play with these enormous simulations. You know, digital twins, live and real-time, instead of waiting for hours. It's pretty amazing stuff. Okay, here's the game plan. We'll start with the big challenge, then introduce NVIDIA kit-CAE. We'll get into its core idea, which is all about describing, not exporting. Then we'll see how it all clicks together. And finally, how you can build one of these digital twins yourself. All right, first up, the real-time simulation challenge. Let's really dig into the core problem here. Why is this so hard to begin with? Why are we stuck with static files instead of live interaction? So check this out. Picture a super complex airflow simulation over an airplane wing. Now, what if you could just grab that wing, change its angle, and see the airflow change instantly? The quote here says it all. This is not a movie. This is actually the real-time inference happening. That's the key word, inference. It's not a video, it's happening live right now. And that leads to the giant question, right? How in the world is this possible when these simulation files are gigantic? We're talking gigabytes, sometimes terabytes of data. Real-time is just not a word you'd normally associate with this stuff. It's usually a go get a coffee, maybe lunch kind of workflow. And this is why. Look at the old way of doing things. It's this long, painful process. You run the simulation, then you export the geometry, then you have to convert the data format, then you load this massive file, and finally, you get to see a static picture. Just a picture. If you want to change one little thing, well, you're back at step one. It's a total killer for any kind of live interactive exploration. So how do we break out of that cycle? This is where NVIDIA's kit-CAE comes into play. It's a whole new toolkit for developers designed to smash that data bottleneck.
So what exactly is kit-CAE? Well, it's an Omniverse-based sample application and an SDK, a software development kit. And that's the important part. It's for developers. It's designed to help them process and visualize these huge scientific and simulation datasets. A good way to think about it is, it's the powerful engine, but it's not the fully built car.
And this quote really nails it. The key word here is sample. It is not a product. This is so important to understand. You can't just go and buy kit-CAE to analyze your data. No, it's an example, a blueprint that shows software companies and big engineering firms how they can build this incredible real-time capability into their own custom applications.
Okay, now we're getting to the heart of it, the big idea. This is the core paradigm shift that makes all of this possible.
So instead of exporting data, the big idea is to describe it. Think about it this way. The old way, exporting, is like trying to find out who directed a movie by downloading the entire 45 gigabyte 4K file. It's insane, right? It's slow, it creates a huge copy. The new way, describing, is like just going to the movie's webpage. You instantly get all the info, the metadata, and if you want to see a specific scene, you just stream that one little clip. It's instant, lightweight, and you're working directly with the source.
And this right here, this is the million-dollar question for any developer working on this. Instead of exporting data to USD, can I describe my data in USD? Just changing that one verb from export to describe is a total game changer. It's the whole philosophical shift in a nutshell. So here's the secret sauce. The process only reads the metadata to build the scene. It doesn't touch the gigabytes of raw data. It's just looking at the table of contents, not reading the entire book. It sees the structure, the variable names, where the big chunks of data live, and uses that lightweight map to instantly assemble the scene. It's genius.
Okay, so how does this describe don't export magic actually work under the hood? Well, it all comes down to a couple of key building blocks that work together.
First up is OpenUSD. You might have heard of it, it's from Pixar. The simplest way to think about it is as a standardized language for describing a 3D scene. It's the blueprint that says, okay, here's the geometry, here are the lights, here's the camera, and this is how it all fits together. It's the common ground for everything.
And then there's this piece, the Data Delegate. Now this is where the real magic happens. It's basically a special translator. It's a little plugin that you write to teach the main application how to speak the language of your specific data file. So whether your data is in a CGNS file or VTK or something else entirely, the Data Delegate knows how to read it directly from the source, no conversion needed. And here's how they work together. It's actually pretty elegant. OpenUSD describes the scene. It's the map. It says, hey, for this part of the airplane wing, I need to show the pressure data. Then the Data Delegate acts as the GPS. It looks at the map, goes straight to the original, massive source file,
finds exactly the little piece of pressure data it needs and serves up just that tiny chunk. The application only reads what it needs when it needs it. Boom, real-time performance.
So we've covered the what and the how. Now for the really fun part, how you can actually get your hands on this and start building your own digital twin.
And just to show you this isn't just theory, look at this number. 45 gigabytes. There was a demo with a 45 gig particle simulation in a standard HDF5 file. That's a huge dataset. And using this kit-CAE framework, it loaded almost instantly. You could scrub through the timeline, rotate it, zoom in, all in real time. No waiting.
So if you're a developer and your interest is piqued, here's your toolkit. The kit-CAE sample is open source on GitHub. You can go grab it right now. NVIDIA has blueprints to show you how to build a full application. Plus, there are self-paced courses and developer blogs to walk you through it. And yeah, it has support for common formats like VTK and CGNS right out of the box.
Look, this technology is opening up a completely new frontier for how we interact with data. It's a true game changer for digital twins, for interactive analysis, really for any field, from aerospace to energy. Being able to work with full fidelity data in real time is huge. So the only question left is the one on your screen. What complex system will you bring to life?